Hello, today I'd like to bring you the report of our Group 15, Diagnosis and Prediction of Diabetes via Overnight SpO2 Signal Based on Deep Learning. OSA is widely considered as a systemic disease that can cause frequent hypoxia during sleep and disorder of biological rhythm and metabolism. The prevalence of OSA is increasing year by year, and it has been proven to be an independent risk factor for type 2 diabetes. However, due to the need for invasive blood tests for the diagnosis of diabetes, many OSA patients with potential diabetes have not received enough attention. Therefore, a non-invasive and portable diabetes prediction method is necessary. The causal pathways linking sleep apnea and diabetes is mostly contributed by frequent hypoxia. It gradually leads to a serious pathological mechanism which increases the risk of metabolic disorders and insulin resistance, and eventually develop into diabetes. From this above, we hypothesize that blood oxygen saturation signal, short as SpO2, could be used to detect the risk mechanism of diabetes and further predict the incidence of diabetes. And this signal is much easier and non-invasive to get than blood tests, so it meets the clinical needs. Since SpO2 is a long-time series, we attempted to use the deep learning algorithm to automatically extract features. Our aim is to input original SpO2 signal and demographic information to predict the risk of prevalent and incidence diabetes based on deep learning. The sample was derived from Sleep Heart Health Study, which is a community-based prospective cohort study for examining the cardiovascular outcomes of sleep-disordered breathing in middle-aged and elderly population. The available data included 5,804 cases. After excluding cases combining with respiratory failure, poor quality of SpO2, and missing converters, 4,705 cases were enrolled in diagnosis study. Moreover, we excluded cases with prevalent diabetes and no follow-up. Finally, 2,902 cases were enrolled in prediction study. In this table, we can learn that in diagnosis study, cases with prevalent diabetes were older, more obese, and more severe OSA than those without prevalent diabetes. Features extracted from original SpO2 were significantly different between two populations. It suggested that the original SpO2 were available to make the diagnosis. The similar results were shown in prediction study. From the cumulative risk curve, we found that individuals with severe OSA have high risk of diabetes. Then we started to establish our model. Due to the imbalanced data and difficulty of data argumentation, we randomly select the cases without prevalent or incident diabetes to make the data balanced. We input age, sex, BMI, and SpO2 signal in deep learning model, which consists of one-dimensional convolutional neural network and long short-term memory. Model performance was evaluated by five-fold cross-validation. We found that deep learning model have more advantages than logistic regression model in diagnosis of diabetes. There was 12% improvement in terms of AOC. The class activation map showed that frequent hypoxia contribute the most for classification. However, in prediction of diabetes, the specificity and the precision improved slightly. Therefore, the model still need other predictions to improve the performance. In conclusion, based on our deep learning model, the diagnostic and predictive risks of diabetes were available separately. Maybe in the future, blood oxygen saturation from wearable devices can be used to predict the user's risk of diabetes. There is still much to be improved. We hope to aid more effective predictors and validate the model in the real world. The above is the report of our Group 15. Thank you for your time and support.